visible light?
Dr. Rick Marshall.
Who invented visible light?
Isaac Newton invented light, or he didn't invent light, he discovered light. And as you can see, there's light everywhere. There's light outside, sunlight. There's light around us. There's light everywhere. So Isaac Newton discovered that light in 1671. And what's up, Chaz? How you doing? All right, so back in 1671, my boy Isaac Newton used colored prisms and had sunlight shining through them, you know? So, what are you doing, dude? And so say like this is my color prisms, all right? I'm gonna take my color prisms and the sunlight is gonna shine through the color prisms and it's gonna start changing color. And you start to see the sunlight shine through them.
I don't really see any difference in the
Okay,
color.
well, it's an example, Sean.
I'm not really seeing it, Andrew.
Here we have Dr. Sean Flannery, PhD, talk about visible light.
Okay, so it's an electromagnetic radiation. That's the main property of this type of light, okay? Yes, so the frequency range is usually around 380 to 750 nanometers. Yeah, that's pretty small. Pretty small.
It's pretty small.
Pretty small, right? Pretty small?
Pretty small.
Pretty small. How does that compare to the other types of light on the spectrum? Well, let's just say it's near the end.
Wow.
Okay.
That's cute.
Yeah, that is very cute. Very, very, very cute. So about like the average wavelength is like, it's about 390 to 700 nanometers.
What's up, y'all? We're out here, 2016, filming a physics video, ready to talk about wavelengths with Dr. Rick Marshall. Let's go. Dr. Rick Marshall, wavelengths, part 1.
So basically, the visible light wavelength is like the same size as a bacteria or virus. Isn't that interesting? Very small, very small.
Pretty small.
Pretty small. Stop zooming on my face. Alright, so where is it on the spectrum? Well, if you're looking at the spectrum and say the biggest one is all the way over here, up on this wall, and the smallest one's all the way over here on this wall.
Yep.
Well,
What are those?
visible light's like right around here.
It's right around there?
Yeah, right around here.
So it's near the end.
So it's near the smallest end, yeah.
Yeah, so it's definitely smaller than
It's
rather
definitely smaller than the
Okay,
biggest one.
okay,
right?
good
The biggest
explanation.
one's like, I don't know what the biggest one is, but the biggest one's pretty big.
Sunlight is an example of visible light. It is caused by a nuclear reaction called fusion. Fire is another example of visible light, and fire is caused by a chemical reaction producing light. A third example of visible light is a light bulb. A light bulb has a current flowing through it, and it heats the filament and produces a light. The shorter the wavelength, the harder the light is to go through the Earth's atmosphere. Visible light makes it through the Earth's atmosphere pretty easily. If the light was not able to reach the Earth's surface, then we will have no daylight. Visible light is used every single day by every single human on Earth. If you walk outside and it's daytime, then you're using visible light. If your power goes out, you will still be using visible light with a flashlight. This type of light guides us through the day. And if it's not being used, then we wouldn't have our phones, we wouldn't have a TV, we wouldn't have a sun, we wouldn't have a daytime, we wouldn't have anything that involves a light. Visible light is the most important light that we have. Without visible light, I don't think humans could survive. Next time you flip on that switch, think of Isaac Newton in 1671 when he used color prisms and discovered light.